So let's get on to the next question, which is question 8. It reads as follows: starting at A00, as you can see in the diagram here, A00, in the Cartesian plane, a line is drawn 1 unit to the right. Okay, so you see an horizontal line. Its length is 1 unit. So this is what you got. This length here is 1 unit. And then it goes up 2 units upwards. So from here to here is 2. So you go up to this point here. All right. Then after that, what does it do? It goes 3 units to the right. And then 4 units upwards. And then 5 units to the right. And 6 units upwards. So in other words, at each stage, if you just travel along these points, then you've got after every 2 moves, okay, we can say, let us track the points. After every 2 moves. By 2 moves, I mean to the right and up. Then we land here, to the right and up. So the dotted ones is what we're going to look at. You can see that the x-coordinate is going to be 1 plus 3 plus 5. Because x-coordinate, it increases by odd numbers. Now there's a formula for the nth odd number. Okay, so it is n squared. I mean the nth sum. The nth sum of odd numbers. 1 is 1 squared. 1 plus 3 is 2 squared. 1 plus 3 plus 5 is 3 squared. So this formula, so the x-coordinate is that, and the y-coordinate if you look upwards now, is 2 plus 4 plus 6. And that is 2 into 1 plus 2 plus 3. And we know that when you add the sum of n numbers, natural numbers, the first natural numbers, is n into n plus 1 over 2. So this is just n into n plus 1. Okay, what does this mean? It means that the coordinates of any particular thing are, the x-coordinate is n squared, the y-coordinate is n into n plus 1. All right, so if you take a random point, so this coordinates, this is n squared and n into n plus 1. And the horizontal one here will still be, it'll be a new one, it'll be n plus 1 all squared. The y coordinate remains the same. And then after that, it goes upwards, and the y coordinate will change. Okay. So now we've reached, this line passes through the point xy, where x plus y is 1035. So you have that x plus y, this is the x coordinate, n squared, and the y coordinate is n into n plus 1. We've calculated the y coordinate to be n into n plus 1. And this is given as 1035. All right, now we can actually solve for n here, because you got n squared. Let me go right to the top here. You got n squared plus n squared, which is 2n squared, plus n. And if you take the 1035 to the other side, you get 0. Now, you can factorize this. It's not easy to factorize, but it does factorize. If you use the formula, you can get the two factors, the formula for the roots. So once you got the formula for the roots, then you can. Once you have the roots, then it's easy to create the quadratic, the factorization. Well, let me just explain that. If you don't know how to factorize this, you should know the formula for the roots of a quadratic equation. Now, this is a quadratic equation. This normally you have 2x squared plus x plus something, right? And that's a quadratic equation. But here you have it's an n. So the formula says n is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So that'll be equal to, the b is plus 1 here. So minus b is minus 1 plus or minus the square root of. Now if you square b squared, b is 1. So it's 1 squared minus 4 times a is 2. And c is negative 1035. I don't have space here. Let me just write this thing at 4 times 2 times 1035. It's negative of that, so I can make this thing plus. So you got 1 plus square root of that. And this is 1 plus, this is 8281. It's 1 square root of b squared minus 40c. Sorry, I've got the square root sign in the wrong place. Sorry about that. So it's b squared minus 4ac is, let's just make this thing. Sorry, I don't have enough space here. Just forgive me for this. So b squared minus 4ac is, b is 1. That's 1 squared. The square root of. Square root of b squared minus 4ac. There are two minuses which we put plus. So this is the square root of, if you look at this, you'll see there's a 4 here. 8281. And the square root of 8281, you can see it's going to be, it's exact. So 8100 is 90. Right? This is actually 91. There's 91 times 91 is this. So you have that this is equal to minus 1 plus or minus 91. It's exact over 2a. And you got two roots. You got 45. And then you got minus 92 over 2, which is minus 46. So those are the two roots. Now, actually, the 2a will be 2 times 2. It's not 2, it's 4. So it's 45 over 2 and minus 23. Now you'll see neither of these ends are suitable here because this n is going to be a counting number. So you'll say, what happened now? N is supposed to be a counting number, and you got a negative number which is not allowed, and you got this 22 and a half here, right? But you see, the things at some point along the way, the line passes through this point. We are not talking about necessarily those points, but some point along the way, it could be here somewhere. So let's see, the closest value of n is 22. So let's try n equals 22. Then the point that we have here is 22 squared, which is 484. And this is 22 times 23. And that gives you 506. Right? And when you work on x plus y in this case here, you got 990. Right? That's not 1035. Okay, let's try 23 because the 22 and a half, we can try the nearest integers to this. 23 squared is 529. And then you got n into n plus 1, which is 23 times 24. And try this thing out. And here you see that x plus y is 29 is 11, 1, 5, 6, and 2, 8. And you have 1081. But we want 1035, you see. So we got 990 and we got 1081. So we wonder what happened here. Actually, we jumped 2, you see. So if I so neither of these corner points work. By work, I mean this point, this number, the point xy is not this or this. So it's possibly that one there. So what do you have? You have a point here which is coordinates of 484 and 506. And when you go horizontal here, right, the x value changes to the next one, 529. The y value still remains the same. and then it goes upwards. Yeah, the x coordinate is still 529, but the y coordinate is 23 times 24. That's the one you get 552. Right. This didn't work, but this one here, when you add the two, you get 1035. So this is the point that we're looking for. That's the point. At some point along the way, the line passes through this point, and we've identified that point as this thing, and calculate x minus y. So x minus y is just the difference between these two. So that's the answer to that question. Okay, so let's get on to the next problem. Oh, so you see, I've got this same solution. You can check it out at the bottom. It's x minus y equals 23. So if you didn't understand or didn't follow what I said, you can always freeze on this and try to understand what the solution is. Okay, so we get on to this problem, which is problem number 9. The problem number 9, it says the following. It starts from 2. You got a table which is built up like this, consecutive natural numbers. So the one, oh, they should have had a 1 somewhere, but anyway, starting from 2, 2, 3, 4, 5, and then it comes here and it goes backwards. 6, 7, 8, comes here, 9, 10, 11, 12, and then suddenly it jumps to this spot here, 13, 14, 15, it jumps to this, and so on. So it's kind of a very erratic. Erratic means it's jumping around here and there. And in this table, now the question is now, where is the number 225, 2025? It's going to be somewhere here, and you want to know what is its location. And what they are saying here is that if I take this number here, for instance, right, I will say its location is the 6th row. I'll put 6 and column C. So 6C is 20. Likewise, this here is 5E, okay? And so on. So we need to identify the actual locality by saying which row and which column it is. Okay, so now I got 2025. So how do you proceed here? These numbers, as I said, it looks quite erratic, but there's somewhere something nice happens. Study it carefully. You'll see that in column B, you got 7, 14, 21. You got multiples of 7 in column B. See? So then you say, okay, let's see, maybe we can get the pattern here. There's two. So these consist of multiples of 7. And where are they? In column, in row 2, it is 7. Row 2 is column B now we're looking at. Column B is where there's a nice pattern. But the 4th row is 14. Row 4 is 14. The 6th row in column B is 21. So what is the general rule? You can see here you got 2 times 1, here you got 7 times 1. Here you got 2 times 2, you got 7 times 2. You got 2 times 3, you got 7 times 3. So in general, 2 times n, 2n, and you have 7 times n. Okay, so the position in column B at the 2nth row this 2nth row, the 246 is 7n. Now I'm going to locate that in this table right at the 2000, whatever n is, and n is going to be quite large for 2025. Okay, so what is n in 2025? We'll have to see how many sevens there are in 2025. So let's divide this by 7, and you get 289, remainder 2. So let's just hold on with that. I want to exploit this thing here, that in the bth column at row 2n, I've got 7n. So I'm going to just look at the next slide here. So what have I got? I've got that in the bth column. Here at the row 2n, here I've got 7n. Right. Now I want to see what the other numbers are using this only. So there it is here. So on this side, you got one less, here you got one more, right? And then from here, it jumps 2 spaces downwards to get to this. And then after that, it goes one, increase by 1 until you come to the end of that line. And then once you come to the end of the line, you jump to this point, then go backwards. So I'm here now. So it means that I started with 1 less, and I want to go up. But remember, I must jump 2 spaces to get to this one. So let me just put this into this diagram. I got 7n here. So here I would have had 7n. I would have had 7n minus 1. Right? It's increasing this way. You get 7n plus 1. And then it jumps 2 spaces. It comes to 7n plus 2. Now you got 7n plus 3, 7n plus 4, and so on. Right. Now, we noticed that 2025, when you divide it by 7, you got 289, remainder 2, which means that 2025 is actually equal to 7 times 289 plus 2. And the remainder is 2. So if I subtract 2 from that, I'll have 7 times 289. Okay. Now this is of the form 7n plus 2. See? Where n is 289. And I can see a 7n plus 2. It's here. Right? So this is 7 times 289 plus 2. So you got 2025 sitting inside here. Right? And the value of n is 289. So, okay, if this is the row 2n, this is the row 2n plus 1. It's the next row. So this thing here occurs in the 2n plus 1th row. So when n is 289, you get 2025 here when you substitute. But when you substitute n equals 289 here, you get 2 times 289 plus 1, which gives you 579. So in row 5, so we've actually found out where this is, right? So the answer is this 2025 occurs at, the row is 579, and the column is C. So once you know that position, if I say row 6, column E, 6E, then I'll go to the sixth row from the top, go to E, and I can locate 1 point. So this is the answer. They wanted to know where is 2025 sitting, and we say it's at 579C. And let's just see. Okay, so there is some argument here. It seems to me it's almost the same, and it appears in 579C. All right, now let's get on to the next problem. Oh, this is problem number 10. This is the last problem that we are going to do. The 4x4 grid in figure 5. Okay, I'm taking it from somewhere else. So this is supposed to be figure 5. It consists of unit squares. The squares are 1 by 1. So each area is 1 square unit squares. And determine the fraction of the area of the grid that is shaded if CD is parallel to AB. Now, when you look at this diagram, you'll see a rectangle. Okay, you got a dot there, you got a dot there. But you'll see that this dot here is not sitting at any of these intersection points, which we call lattice points. It's sitting somewhere in the middle, and D also. So we don't know where C and D lie, but we know A is at an intersection point. Okay, so how are you going to find the area here? Because this thing here is, it's some kind of a fraction here too. So there should be some way of finding the area. All right, let's look at the outside. Right? We've seen many times. Look at the outside. Okay, the outside, you've got that triangle, and you have exactly the same thing. This is a 1 by 2. So we can have a 1 by 2 here. And here too, you got a 1 by 2. This thing goes right up to this intersection here. Right? Now, that seems to me that you have to clear the pattern here and to draw this coming down like that. And once you do that, then you get that part there, because 1 by 2. All right, now that's very nice now, because now by drawing this, I can see I have a square here. So the area which we're looking for is the area of this large one. Let's find this, let's call this area A. I'm going to make this thing sit in red, in black now. So this area here, if you look at this area of the square, and this is a square. Why is it a square? Because you've got these 4 triangles are all the same size. They're 2 by 1 triangles, so they're congruent. They're exactly the same triangle, right? Congruence means they are identical. So these are identical triangles, and you can work out the area of A. The area of A, which this yellow part on this side, is well, let's not confuse it with that A there. We'll call it area A. Now, how do you work out the area of this It's the area of the full square, which is 3 times 3. So this whole thing is the area of the square, yeah? Minus 4 of the blue triangles. Minus 4. And what is the area of the blue triangle? It's 1 by 2. It's actually half a rectangle. This rectangle here, its area is 2 because you got 1 square unit, 1 square unit. And this diagonal of this rectangle that we are pointing to, it divides this thing up into 2 equal parts. So the whole thing is 2. So this one here is 1. So that's the area of A, which is 9 minus 4, which is 5. So we worked out the area of this. Now, if we want to work out the area of the shaded region, you have to add. You'll have to add this part here. Let's just take this thing out. Okay, so I have to add I need to know the area of this rectangle. Or this area of this triangle. I'm sorry. I've already got this area of the square is n. So I need to work out the area of the rectangle. What is the area of this rectangle? Now, if you watch carefully, you will see that the area is twice the following. You see the area that I rubbed out? If I kept that in, this is what I would have got. This is the area that I erased. I just want to make it quite clear. So I erased it and I put this back. Now I want to calculate the area of this thing here. But if you look at this carefully, you'll see that the area of this yellow part, area of rectangle, is equal to 2 times the area of the triangle. See this tilted triangle. Whenever you got a triangle and you got some area like this, got the same base as the parallelogram, need not be a rectangle, it could be any parallelogram, then this area here is equal to half the area of this whole thing. Right? Because the area of the rectangle is length times breadth, and the area of the triangle is half length times breadth, half base times height. So your base is your length times the height, which is the same as the breadth. So the triangle, it's easy to see the area of the triangle because it's a 2 by 1 triangle. So that is, the area there is 1. The area is 1. And therefore, the area of the rectangle shaded rectangle. Right. The area of that is base times height. So it's twice whatever we got here. Because this area is 1, half base times height. This area is 1. I've got it there. And therefore the area of this rectangle will be twice that, which is 2. So add the area of the rectangle, it's 2, therefore the answer is 7. Because the area, we've split it up in 2 parts. One is the area of a square, which is 5, and then the area of the rectangle, which is 2. And to add the 2 areas, the answer is 7. So that, people, brings to a conclusion the 2025 junior team competition paper, which had 10 questions. And we have just concluded question 10. That takes care of the solutions to this paper. Thank you very much for listening.